Okay, I got a request from a student a few minutes ago to talk about assigning oxidation numbers. So what I did was I set my whiteboard up over here. We'll look at that in a minute. And I also took a snapshot of an explanation. I didn't get the whole explanation, just part of it. So let's see what we can do here with this. All right, so first of all, this is hydrogen phosphate. We memorized that in one of our polyatomic ions, hydrogen phosphate. And if I were you, I would use it now. I would use the opportunity to practice the nomenclature, right? It's HPO4 2 minus. It's hydrogen phosphate. And I would say it out loud if I were you. Please consider it. All right, so next thing I'm going to do is I'm going to go here to my rules and I'm going to say first decide whether the atom, this is the snapshot for the explanation, okay? First decide whether the atom is an atomic ion. Is this an atomic ion or not? Is that an atomic ion? No, it's not, right? You've got lots of atoms in it. So it's going to be a polyatomic ion. All right, so far, it's not this one. Next, decide whether the atom is part of a molecule made from only one element. Is this a molecule made from only one element? No, it's not. Okay, let's move on. Next, try to use the fact that atoms of certain main group elements strongly prefer one particular oxidation state when they are part of a molecule. See if you can use these strong preferences to assign oxidation state of the atom. And this is going to do it for us, okay? So we know, I'm going to go to red. And by the way, when I'm doing this, I will use a different color if possible, and I'll put my oxidation states up here and all my notes down here. Notes. And oxidation states up here. It doesn't matter where you put them, but always put them in the same place, all right? So I'm always going to put mine here. Well, this is a main group element. Hydrogen is, and hydrogen has a tendency to take on what charge for an oxidation state? +1, right? And here's a main group element. So that's a main group element. Here's another one, oxygen. And oxygen has a tendency to take on what charge? -2, right? Okay. Right, so now I think with those notes there, it looks like we're looking for phosphorus. Oh, I forget what the question was. Now let's go back over here and see, was the question just one of those? If it was, we're done. No, it's asking about phosphorus. Okay, so we have more work to do. So let's go over here now. That's a circle, meant to be a circle, by the way. I'm going to get rid of that circle. We don't know what phosphorus is, but we do know this, that there's only one hydrogen in here, and it has a +1 charge on it. And we also know that there's 4 oxygens, and they all have a -2 charge on them, right? And we also know that the charge of the overall ion is -2. Right? Okay? And we know that the sum of all these things must be -2 then, right? So 1 plus blank -8 is equal to -2. So it looks like this is blank -7 is equal to -2, right? Let's add 7 to both sides. Oh, that's a minus right there. Got it? Let's add 7 to both sides. Blank is equal to 5. Okay? So it looks like the oxidation state of phosphorus here in this case is 5. Let me go to a different color. It's getting a little bit busy right here. Must be +5. Okay, does that make sense? So what I did was I took my +1. There was only one of them. My +5, there was only one of those. And 4 times -2, right? Because there were 4 oxygens. And I added all those up, and I got 1 plus 5 is 6. -8 is equal to -2. And that's exactly what it was, right? You see that? Okay, so it's +5 for that first one. Let's go do another one. Let's go do another one. And I'm going to patiently go through this just like you ought to be doing. Okay, +5. Now sodium. Let's go back through. It's sodium plus. So first of all, decide whether the atom is an atomic ion or not. The oxidation state of an atomic ion is simply equal to its charge. Is this an atomic ion? Sodium plus. Yes, it is. So the explanation says then the oxidation state is equal to its charge. Let's go here and say then this must be +1. Okay? Now let's go on to this one, O2. Now first decide whether it's an atomic ion. It's not. O2 is not ionic, right? There was no charge. The oxidation state of atomic ion is simply equal to, well, it doesn't matter because it's not that. Next, decide whether the atom is part of a molecule made from only one element. Like Cl2 and O2 are both oxidation state of 0. Oh, this is O2, right? But can you see how that is a molecule made from only one element? It's a molecule made from only one element. It's just oxygen. So its oxidation state must be 0. Just a minute here. Oh no. Oh, of course. Okay, there you go. Now, let's go to H2O. So we're supposed to do the oxygen in H2O. Let's go back over here to our rules. First, decide whether it's an atomic ion. It's not, right? It was a molecule. Next, decide whether the atom is part of a molecule. Yes, it is, made from only one element. No, so it's not that. Next, try to use the fact that the atoms of certain main group elements strongly prefer one oxidation state or another. So let's go back over here. It was H2O, right? And it's the oxygen we're doing. So let's go to our notepad and say H2O. Now, we know I'm going to do my oxidation states up top. My notes down below. We know oxygen or hydrogen has a tendency to take on a +1 because it's a main group. We know it's +1. And oxygen has a tendency to take on a -2, right? Well, there's two +1s. That's going to be 2 times +1 plus -2, right? It's going to give me 0. 2 minus 2 is equal to 0, which is exactly what I wanted because there was no charge in water. So yeah, this is legit right there. The oxidation state of oxygen is -2. All right. I think I might leave it at that for now. Now let's do one more problem. So oxygen was -2, right? Okay, we'll check it. We're going to see a bunch of greens here. Awesome. Okay, let's do it again. We're going to just go through that flow chart again, right? So I've got those notes out in front of me. Eventually, I don't need those notes anymore. Oops. Oops, oops, oops. I don't want that. I want this. Okay, battery's running low. Just give me 1 second. I'm going to yell into the camera. Hey, William? Okay. All right, so H2. Let's do H2 first. Okay, let's come here. Let's get rid of that. Let's put a new page in here. And let's say, William, do you mind putting my power source in here? Thank you. I need to get plugged in. I'm low on battery. So H2 is that one we were doing there, right? You see it there? It's here, H2. And I'm supposed to decide what H2 is. So we're just going through our flow chart. And I'm going to make notes here. I don't want red. I want to use that for other things. Let's go with black. H2. Let's go with our notes. Our notes say, first of all, decide whether it's an atomic ion. It's not. There's no charge there, right? First, decide whether the atom is an atomic ion. It's not an ion. There's no charge. Next, decide whether the atom is part of a molecule made from only one element. Aha, that's what it is. Look, it's a molecule because it's H2, but it's made from only one element. It's just H. Okay? If that's the case, if it's only made from one element, then its oxidation state is 0. Okay? All right. H3O plus. Thank you, William. H3O plus. All right? So first of all, the first rule is to decide if it's an atomic ion. It's not an atomic ion, right? Because there's more than one atom in it. You see it? There's 4 atoms, 3 hydrogens and 1 oxygen, so it's not an atomic ion. Next, decide whether the atom is part of a molecule that's made from only one element. No, it's not. There's a hydrogen and an oxygen, right? Next, try to use the fact that the atoms of a certain main group element strongly prefer one oxidation state. Yeah, because they're main group elements, right? And so we know oxygen has a tendency to take on a -2. Oops, whoa, 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 whoa. Sorry. Oxygen has a tendency to take on a -2, right? And hydrogen has a tendency to take on a +1. So remember, our oxidation states are going to be up here. Our notes are going to be down here. So +1 times 3 gives +3. -2 times 1 gives -2. And that gives me +1, which is perfect. Right? So yes, these notes all work out perfectly. It turns out that certain main group elements strongly prefer one oxidation state. Oxygen prefers -2. And actually, that's all I was being asked, right? What's oxygen here? So let's say -2. Okay, copper. Let's go here. It's copper 2+, right? Let's go over here. First, decide whether the atom is an atomic ion. It is. It's copper 2+, right? So the oxidation state of an atomic ion is simply equal to its charge. And look at that. There it is right there. 2+. Just one atom. 2+. +2. What's the language that's being used? It's plus. The oxidation state, to put the pluses and minuses are going in front. So let's put it there. It's +2. Now copper oxide. Okay, let's put this in our notes here. Copper oxide. So first of all, we have to decide whether the atom is an atomic ion. It's not. It's not ionic. There was no charge there, and there's more than one atom. Next, decide whether the atom is part of a molecule made from only one element. No, it's not that either, right? Because it was a copper and an oxygen. Next, try to use the fact that the atoms of certain main group elements strongly prefer one oxidation state. All right, that's good enough. So let's go here and say, well, oxygen prefers a -2. And so if it's -2, and there's only one of them, and whatever copper is going to be combined with that to give the charge of this molecule, which is 0. There's nothing there. It's not really a molecule, it's a formula unit, but, right? So this I can see must be a +2. All right? So let's go over here and get a +2. Copper oxide must also be +2 because it's with an oxygen, which is -2. All right? So let me just quickly blaze through here again. Hydrogen is 0. We knew that because it was a molecule with only one element in it and no charge, so it must be 0. Here's oxygen has a tendency to be -2, right? That's with hydrogen, so it all works out. Copper is the atomic ion. It's +2, and sure enough, +2. All right, we like that. We like that. All right, so this video is probably longer than it needs to be, but hopefully that was plenty of practice for you, and I hope you will let me know what else you want to see. Good luck to you.